What are the benefits of being green? You will hear it this morning at the Project Cargo Summit 2020.
Project Cargo Summit 2020 is made possible by Port of Rotterdam, Liebherr, Lubbers Logistics Group, Mstar and the Steinweg Group.
Good morning, ladies and gentlemen, and welcome back to the second day of the Project Cargo Summit 2020 online. My name is Tobias Pievers. I am the editor of the Project Cargo Journal, and I will be your host today. Although it may not be at the top of our minds at this moment, we are still faced with an incredible sustainability challenge. In today's program, we will talk about the benefits of being green, how we can create cleaner vessels, and what you can expect of the renewable markets. We will do that together. As you may have noticed, our webinar platform has a chat function, and I want you to use it vigorously. I want you to ask questions and participate. Not in the least place, because your questions are probably better than mine. Before we start the program, I want to share a poll with you. I want to know how you currently feel, what the best way forward is for the multi-purpose and heavy lift fleet. Do you think the fleet of the future will be driven by hydrogen, by LNG? Do you think there will be a mix of renewable solutions? Or do you think that diesel will remain king for quite a while, but there will be a focus on efficiency gains? If you answer the poll in the chat, then we will first go to our first speaker, and we'll get back to it after. While you answer this, we will go to the first presentation of the day. And our first speaker of the day is Executive Partner Dirk Neugebauer of Esplendor, who will share some very interesting ideas about going green in maritime.
So good morning, everyone. Thanks for having me here in this summit. I will run you through some interesting facts about becoming more sustainable in the containerized marine industry and what we think might be the future about. So I think it will be very interesting for some of you, as we really went through very interesting trends in the future, and we project them then in the back. So what is sustainable shipping at the end of the day about? As you all know, it's a holistic management concept for sustainable development. I will explain later what is sustainability for you about, and because it's not only about becoming more green as well, you have a social responsibility if you really want to stick to the SDG goals. What we think, what the environmental footprint will be about for sustainable solutions, it's all about new emerging technologies, 3D printing, AI, cradle-to-cradle thinking, what will immediately impact the way how you produce goods, how you do the port-to-port transportation, how do you end-to-end transportation means, and how logistics as such will change, and what does it mean for your business models, right? Next. We think SDG is one way to do sustainability, but it's not the end of everything. Usually what we propose is to have as well a systemic thinking for holistic solutions, namely by circular economy. I think you have already heard of this. Circular economy is really living up to become away from linear, more circular in everything what you do. So let's make a little dive into the logistics, what you are mainly dealing with. If you think about the global logistics on steroids, it means that we have exponential technologies in the background emerging. Next. What is exponential technology about? Exponentials, I think we have all realized this in the last 20, 30 years. The processing power became more cheap. The more cheaper it becomes, the more accelerated technologies can be come and commercialized to the market. Just to name some, sensors, super interesting, AI, virtual reality, AI. If you bring these things together in a more exponential growth pattern, then you have a very interesting view on new technologies. You have a very different impact how you can operate in the vessel industry, in the marine industry, things like with machine learning supported and leveraged, how you navigate, how you can do asset tracking, and all these things can be achieved globally for an affordable price tag. Next. So at the moment, we have a huge opportunity, I think, with the new technologies. AI is one, but as well autonomous marine activities that we see. Next. So I think for bringing all these exponential technologies together, I think we have a good moment in time to really do business in a sustainable world, as everything now has a focus to become green. The enabling technology behind is, as you know, it's connectivity. It's 5G and 6G wireless networks. For the one of you, what is 6G? It's quantum communication. So satellites are already in place that have already proven that you can have a hyper connectivity wherever you are, besides satellite networks. Edge computing, that really the ships can talk to each other. Reverse logistics is interesting for you. How can you go through the supply chain, not from the start, but from the end to the start? What helps you really to optimize along the supply chain the different parties that are part of it. One thing I want to mention here, materials genome project. That's quite interesting for you as a owner of cargo and a vessel or even a fleet, because you can improve even the material of the things that you carry with you, but as well the way how you operate with synthetic materials based on this genome project. Okay, next. So let's go in some questions. So if we think about the current supply chains, if you reward the whole people that are part of your operations, of your supply chain as such, how can you incentivize them? If you would incentivize them through a liquid supply chain, so they would get money if they stick to more SDG goals, this might be an interesting approach to become more greener, because then you get rewarded for becoming green and be green. Next. So what if even the procurement could become access to global logistic trading platforms for end-to-end delivery across the supply chain, across the verticals, because these guys are usually are in charge to do the brokerage. I think what's quite interesting for you to understand in the future, we will have artificial materials, we will have as well freight that can broker itself along the supply chain through all life cycles in the circular supply chain even, means a material in the circular economy could broker itself into the next cycle. The same would happen for freight. So before it's even on the ship, before it's even on the logistic supply chain, it can already broker and negotiate it on its own behalf, on the behalf of you, where it should be transported through and where, to have the most and maximum sustainability footprint available. Next. So I think what we face these days with a very different supply chain and the way how we deliver things, logistics can improve in the next 10 years in a way that we don't go from date delivery to hour delivery. How can we achieve this? This is really this zero time fulfillment. So you can either assemble products on the move when you have them still in your container or in the car even. What is the automotive industry already doing? Or you literally just 3D print. And I think we all agree in the future, most that are familiar with Star Trek know there are ways how you can print 3D print organical material, but as well products. I think we will rush into this time in the next years. So if you have then the warehouses as a micro infrastructure around, the more greener the cities become, the more micro warehousing you will see, and they can even adopt based on data insights of predictive demand. So the smart infrastructure already knows what amount of goods people need months and even years ahead before they even know on their own. So if we then say the orders could be assembled on the move, on the vessel, on the ship, in the car, in the van, wherever, you see that you will optimize the whole supply chain and the sustainable footprint a lot, because you just eliminate parts of the supply chain and the logistic chain based on such goals. So if we then move from a decentralized responsive pickup mesh network to then a very different delivery approach, I think this will help us to become more green, more efficient, because we will eliminate useless waste paths and decarbonize completely the industry. So the local demand of products will impact immediately then what is the logistics setup? What do we need, where, and how much do we need? And can we replace things that we know these days with new thinking models? I think this is a bit provocative, because I'm coming from Luxembourg. We have one of the licenses for moon mining. So we are allowed, besides the US, to do moon mining. So here comes a very new challenge, that we need even interplanetary connected supply chains. So this could be, and Elon Musk shows it even, where the rocket was landing on the sea, on the ocean. If you think about a very different three-dimensional supply chain model, this has even an impact then on you guys. So what I have talked about, and we can now rush a little bit through it, it's based on mega trends that we see, and it's an ongoing library. We stop here at 2030. Usually we look even beyond to 2040 and 50, what's cooking. I think what is impacting then your industry, if we replace food and water with alternatives, lab-grown meat, what is already already available, we will reduce dramatically in general our sustainability footprint and index, or the city act as a farm. So we eliminate again goods that you usually ship from A to B. If this is going to happen, what is the impact then for your industry, and how can you become part of it? The whole healthcare industry is massively disrupted in the next years. So it's a transhumanism future. So we don't have medicine in a traditional way. We might have little nanobots circling around in our body, and they will give you the dose based on your own conditions. If this is going to happen, as you see, it will also reduce again the way how much goods we need to bring on the move from A to B globally, and even in trading markets. The human being as well, and Elon Musk was showcasing this with the link that he was demonstrating some 3 weeks ago. It's about enhancing the human being. Maybe we see a superhuman. This is one belief that we see at the moment that might happen. So we can even connect the brains then, or we will face a super intelligence. So it's like that we all know from Hollywood, that then there's one AI that is controlling everything globally. It's a bit far away, because we have limitations in the algorithms at the moment that we know, but we will face more and more intelligent systems that are not only supervised or unsupervised, but they will even learn on their own. The logistics in the future is massively disrupted by autonomous distribution. So the things can carry the goods to the place where you need it in very different vehicles even. It could be by drones, or if we go to the next slide, what is already happening, by the way, or we have a fully automatically dispatch and flight even at the port. So there's exactly nobody interacting with the goods. The shipping industry will mainly face then a human hands-free operation, so that really the goods are fully automated, shipped from A to B. The carbon footprint becomes nearly zero. You have super low energy consumption on a vessel, because it's mainly run and operated by machines. If you do this in that way, you have a zero unplanned downtime, because the full maintenance topic becomes more self-steered. So the less human interference you have, the more accurate can be the model in the future, how you operate a vessel. I think an underlying element is the internet. As you know, if we connect IoT and all these things, how do we even work together? We as a human being with machines. What we see 3 weeks ago, playing communities are more and more now become a reality. We will face a 4D internet. 4D internet is everything about a fully digitalized world. It's the digital twin world where you have a static model enhanced with dynamic data, what allows you to do very different simulations of operational scenarios. And we see already that quantum computing has reached us. This was predicted for 2030, 2032. As you know, 2 years ago, I had a speech already on a 5G conference. We had the first working trial of quantum communication satellites globally in India, from China through satellite to Jindum. And this has nothing to do with speed, it's about security. And security is a very important part in the future of your industry. Next. I think some of you guys have seen this. The more we are facing automation, the more robots we will see. And it's not really about replacing humans with robots. It's about how we can interact and work with these guys together, because they will just enhance human intelligence. We will see a lot of automation in the industry, what will lower the carbon footprint. It will lead to a decarbonized transit that we can enable by this, because complete automation, and maybe you know this example 3 weeks ago, this was this first vessel that was fully automated, running from a port to the other port, the Ferry May project, and this was successful. Means you can really so it's already the starting point of a fully automated transportation mean on the oceans, and this will allow you to really have a very sustainable, foreseeable business. So some of you could say, wow, that's all nonsense what he's telling us, but we see already the first evidence of such trends in the future that are happening now. Next slide. So the environment around us, if you have IoT sensors on a vessel, if you have wearables, you have different ways to communicate with artificially smartened material around you. That can be the ship, that can be the port, that can be everything around you. This technology can already create relationships with you. If it can create relationships paired with spatial intelligence, it can even foresee the next steps before you know them. So it can optimize routines, guidance, way how you do your tasks, your daily routines on a vessel if you have this interoperability layer. We see more and more cognitive things. So a ship can talk with another ship, a fleet can talk with the port, and the port can talk along the whole supply chain, even going with this retrocasted way in the supply chain in a very different way. We see, as I already explained, from a weak AI more going into a strong AI these days. There was this OpenAI project now launched in the next level, the GPT-3 model, where people were really amazed how far we are already with AI algorithm that can really understand and can partially give you reason why it has taken decisions with a proof why and based on what insights. As I mentioned, robots will become part of our society on a vessel, on the harbor, in the whole manufacturing chain. And we need to figure out, it's not only human-centered, it's post-human-centered time that we are stepping in. So we need to figure out how we can work together with robots, but this is anyways already happening. Autonomous shipping is a major topic here, that you have a self-aware multimodal logistics model. Means you have not only the port or the port independent
I think we have a little technical problem. That is, of course, one of the issues with the digital age, connectivity, as was mentioned. I do think this is a very interesting way to have a glimpse in the future. Supply chains will change in the project cargo market. Will they change quick? At the moment, you would say there's no way these cargo flows will be moving in that kind of direction very soon. But if we look at markets like hydrogen, for example, which will, if we do go to hydrogen, that will require much less quantities, so maybe also less projects. There could be a shift there as well. I think we do have connection again now.
Yeah, I'm back.
Yeah, okay, sorry. Perfect. I'll hand it over back to you.
Okay, thanks. The missing piece in everything what I have said so far, I think what I have not put in every thought is where we see even EV coming into the marine industry, hydrogen, all these alternative ways how to fuel the thing. I think the threat at the moment, if we really want to reach a very sustainable marine industry, is that you need to have measurable next steps how you can optimize it. SDG goes as one. There are groups and initiatives at the moment that have translated them into 6 transformational areas that you can step by step have a more tangible result. How you can lower energy consumption of a vessel, the whole supply chain and everything beyond. So for us, the sustainable business drivers this is really a low-hanging fruit. How can all this technology, everything what I have explained, help you to optimize the use of fossil fuels or alternatives? I hope we go away from fossil, but machines and algorithms, the more smarter systems can help you to lower fuel consumption dramatically. Can you go one step back? Sorry. Okay. Resource waste is a topic where you can stop. Where you can do the resource waste optimization. It's on the ship, it's packaging, it's everything where you as a company can as well help with new technologies, new materials to optimize it. Ideally, we reduce the pollution, so we decarbonize the whole way how we do the business. And this gives you opportunities to get new monetization models even in. Because if you go from recycle to more circular business models, even on a vessel, even along your supply chain, it will bring, and you can even broker it before you try to resell it in the next cycle. And you can monetize your materials 2, 3, 4 times. The energy recovery, I think, is a huge topic on the ship, how you use the over energy. And efficiency and time, this is mainly driven by data, IoT, interconnectivity layers between ships, vessels, and ports. Next. I think the only thing that you have to consider as an industry are 3 things, the key topics, the economic sustainability. So still staying profitable if you go in such a future that is more sustainable, where you really want to improve and lower your carbon footprint as an industry. You want to use and test and elaborate, but still you should live. The social sustainability is how you take care of your people. We see there's more automation, there's more robotics coming in. We have to take care of the people that work for us and they're part of the family. If you want to accelerate the sustainability as such, you can environmental sustainability, just to close this topic. It's really take care of the ocean, take care of what is your operational environment about, and what is your part that you can contribute to have a better, more sustainable world. Finally, if we go to 3 slides.
I have to stop you there because we do have a time limit. It does sound very interesting. I do want to ask you a quick question. Because this is, for many of us, this will still be a glimpse into a far future. You said that future is not as far away as you think. Yesterday, we talked about digitalization within this industry. And there we were still talking about, okay, how do we move away from an Excel-based platform? If you look at the shipping market, and this is not just project cargo, but this is almost the entire shipping market. it is still quite a traditional industry. So what do you expect will happen here? And will these other modern logistics changes really have an impact on shipping, or?
Yeah, definitely. Because even if you are working in a very traditional industry, I think what helps you to go in the next transformational step or level is if you do it more in a humanized way. If you humanize technology, that people are not afraid, but you see there's a value, a meaningful value for their current operations, for their current work, that helps them to augment their intelligence. It enhances their intelligence. It's a supportive element besides the typical stuff. And if you package it in the right way, people are convinced because they need to see, they need to have tangible results and impact on their daily life. Can you focus on different things? Is it more profitable for them? You named Excel sheets. Who wants to work with Excel sheets? If you have a very different way how to get the information out of the system that is telling you not in columns what is your profitability about or what is the maintenance windows about, it gives you very clear, easy, big data informed decision-making opportunities. And I don't know, by voice. People will adopt this technology because it's helping them. Technology needs to be humanized, and technology needs to be the answer on the why and the what, and not the other way around. We don't want to throw technology on this industry and then you say, okay, now what we are doing with it. What can technology solve? What is the key issue to have a more sustainable business model, especially if we think about resilient supply chains that are more and more even pushed through the current pandemic into the market, and this will impact everyone.
I think that is a good time to stop you there, Dirk, because we really need to move on. I think you can keep talking all day. It's really interesting, and I think one interesting point to take away from it as well is I remember that in 2015 I was writing about autonomous shipping, something that will not be here before 2030, and there are currently some really concrete projects happening, and these ships are actually coming much sooner in 2022 or 2023. So there is definitely some of this movement already being seen in shipping as well. Okay, thank you, Dirk, for your presentation. It was very interesting. We will continue with our next guest. With me in the studio is Harry from DEC. Harry is a naval architect, and at DEC they are working at a modular engine room for coasters. And that is partly because it is still difficult to predict what kind of fuel we will be running on in the near future. Harry, the floor is yours.
Good morning. Thank you, Tobias, and good morning to everyone who's listening in on this lovely meeting. My name is Harry. I'm from DEC Maritime, and today we're going to take you through some of the things we're working on in terms of what can we do to make our industry future-proof at DEC Maritime. Well, to kick it off, I mean, future-proof is a wide term. What do we understand as being future-proof? And you can take many different angles on this. What we choose to do is we choose to look at two main points, and you can see those on the slide behind me. We're talking about especially things that we can do in the next decades when it's going to be very unclear where we're going. We're talking about maximized energy flexibility, and then also on the same time minimizing the energy requirements that we need on a ship. Why to maximize the flexibility? Well, you want to be able to ensure that a ship that you design now can still operate in 20 or 30 years when we don't know where our power is going to be coming from. And you also want to reduce the dependence on a single power source, maybe. Now, as diesel is king, as mentioned earlier, that's not something that's really sustainable in the long term in general. And then on the other side, you have the minimized energy requirements, which is very concrete. I mean, the less fuel or whatever power you use, the less your costs will be. And also, if you still use fuels that emit greenhouse gases or other pollutants, you reduce those emissions as well. So I'm going to start off with maximizing the energy flexibility, and that's also what Tobias mentioned in his introduction. What we're doing here is, like I said, diesel will not be king forever. It will not remain our primary source of marine power. But the problem is, in the next 20 years, no one really knows which direction we're going to go. We know it's probably not going to be diesel. But is it going to be hydrogen, ammonia, methanol, battery packs? The list goes on and on and on. And there's no one right now who can tell you with certainty what the next answer will be. However, at DEC, we're looking at solutions to get around this so that what we do now will still be valid when the final choice is made. And our solution to this is to not integrate the power source of the vessel, of any ship, into the structure of the ship as is currently done. The result of this is a little concept we like to call the future trader. It's a small general cargo ship. In principle, it looks like a regular general cargo ship, but it has a little trick up its sleeve. Instead of integrating the full diesel powertrain, as you would normally do in a vessel structure, this vessel only has an E-motor, an electromotor, integrated into the ship, connected to the propeller. And then what we do is we take the source of that power to the E-motor, we just place it on the aft deck of the ship as a modular engine room, which we call the power pack. And what this does is it provides electrical power to the ship. So what that means is that you have a ship that is fed by electrical power and does not care where that electrical power comes from. And what that entails is that you can have a ship that now is able to run on a diesel genset and therefore can be taken seriously in today's market. But in 20 years, or 10 years, or 5 years, when an alternative is available, for instance, batteries or hydrogen, you can simply swap out the engine rooms and provide the power in a different way. Regarding energy flexibility, it's a nice concept, but it is something we are working on as a concept still. It still needs to be developed. But it's not the only thing that you can do to make your designs future-proof as a ship designer. As I mentioned, you can also very seriously take a look at minimizing your energy requirements, because whatever energy you use, it will always come at a cost. And therefore, minimizing your energy requirements will always save costs and also will save emissions, other logistics in the production of the fuel. It trickles down quite far. And as designers today, I mean, you have a lot of advanced tools at our disposal, which we can do to help reduce the required power of a ship. I mean, we're really looking at modifying the hull and the powertrain so that it really requires the least amount possible. Let's go back. And these three tools, there are three tools in our toolkit that we really use a lot. We use parametric hull design, we use computational fluid dynamics, and we also use automated optimization. And all of these tools, the methods behind them are quite complex, but actually the implications are fairly practical and it's fairly easy to grasp. So I'd like to go through these real quick to give you an idea of how we design ships these days to be as energy efficient as possible in that respect. So starting with parametric design, and I found a definition on the internet of this, which I have to turn around to read, which is parametric design is a process based on algorithmic thinking. Then there's another bit of the definition, where the relations between elements is used to manipulate and inform the design of complex geometries and structures. Well, I'm giving this presentation and even I am confused. But what this in practice means is fairly simple. The hull of a ship is a fairly complex geometry to define, to understand, especially for a computer. So we take that geometry, or a part of that geometry, and we make it easy to understand for a computer. And this still sounds a little bit abstract, so I like to give a short example in the form of a bulbous bow, which just lends itself well to this, to explain this. And what we have here on the screen is we have a bulbous bow which is defined by three parameters. You have the length of the bow, the width of the bow, and the tip height of the bulb. And with these three parameters, you can see 6 examples on the back here. You can really easily make lots of different variations. Now, which ones of these variations are most valid and which will work well or not, that's the next question to answer. But what to take away from this, the most important thing that parametric design gives us is it gives us flexible and easy to vary hull shapes quickly, and also something that will be understood by a computer. So with these hull forms, with these parametric hull forms, we can put these through CFD. And CFD is often seen as a tool to produce pretty pictures of ships sailing through multicolored waves. But it's not really what we like to use it for. well, it does help, but what's most useful to us as designers is that you can really accurately calculate the resistance and the propulsion power that's required by a ship. You could see it as a digital towing tank, really. And by now, as of 2020, this technology has been extensively validated. There's industry-wide acceptance for this, and it's readily available. We use this every day at DEC at the push of a button. So to take away from this is that you really get accurate hull predictions and power predictions from CFD, which allows you to predict how much fuel you can save for a given hull form. Now that we have those two components, the final part of this toolkit is to go through optimization. And again, I found a definition on the internet, which is slightly simpler. Optimization is the selection of the best element from some set of available alternatives. Now, there are many, many algorithms that exist to find you the best solution to a certain problem in a certain amount within certain constraints. But what they all have in common is that they simply try a bunch of different variations and see which one works best. And that's really all there is to it on face value. And the real trick is to use, of course, automated optimization, where you tell the computer what to do, how to make these variants, and it can go through hundreds of different designs, and they can all be checked at low cost. And this is in contrast to a traditional approach where when you're doing manual iterations of a design, you can maybe only do a handful of different checks. Okay, so the computer can make variants easily. How can it do that? Well, we've discussed it already. We have our parametric hull forms, which can be easily modified by a computer. How can we evaluate how well these hull forms are going to perform? Well, we've talked about that as well. We use CFD. And in the combination of these three tools, you can really start from day one of a design to optimize its energy requirements and to really bring those down as far as they can go. So to wrap it up, what are we working on right now? Well, like I said, this is all stuff that can be implemented in today's designs. So we use this approach to all our concept designs, all our further designs to reduce the energy consumption. We're heavily working on developing this power pack concept, as we really believe this is a really good way forward for the industry, especially in the next decades. And we also use our advanced tools, particularly CFD, to gain more insight into what else costs power on a ship. It's still very much in progress, but I hope to be able to share more on that soon, so keep an eye on our channels. And with that, I'd like to wrap up my part, hand it back to Tobias, and over to Guus at Koningschip.
Hardy, thank you for your presentation. I have to say that I write about sustainability and ship design quite a lot. And there's always a press release always says that a ship also has an optimized hull design. And I always thought, okay, so how many times can you optimize a hull? But with that picture of the many shapes just a bulb can have, that became a bit more clear. We will first go to the next presentation, and then we will do a joint Q&A session. So with us is also Guus van der Bles of Koningschip International. And Koningschip is the ship designer, amongst others, behind the new Spliethoff and Wijn Barents LNG vessels. Guus, you will present your view of the future, the multi-purpose and heavy lift vessels of the future. Take it away.
Thank you very much. Good morning, everybody. I'm glad to be able to present it in here. I want to focus on reducing the emissions step by step for sustainable project cargo shipping. Next one, please. Short introduction on Koningschip International. We are a design office started in 1952, located in Groningen in the Netherlands. More than 2,000 vessels of our design were built, and actually also the one in the right below corner, which was the vessel that you saw in the presentation before in the CFD picture. It was designed by Koningschip, to make that clear, and I'll show a picture later on. Our focus, we have a lot of focus on R&D, on research and development, on the combination of economy and ecology. As the first speaker indicated, that's really important, as it is. Always reduction of fuel and emissions, propulsion, and we are investigating heavily on the effects of propulsion on LNG, methanol, hydrogen, and other things. Next one, please. And we did do a lot of investigations in wind-assisted ship propulsion. I'll come to that later. On the top pictures, you see some examples of that. And nowadays, we're quite heavily investigating CO2 capturing on board of vessels together with TNO in the Netherlands. We always are looking for practical, applicable innovations. Reducing the emissions step by step is following, generally spoken, 5 steps. The hull design is the first one. Always focus on the lowest resistance using the tools presented before, going for the lowest resistance. Second step, as important, focus on the propulsor, on the large diameter propeller and optimization of the propulsive efficiency, which is not always behind the hull with the lowest resistance. There is a trade-off in optimization about that. Third step is find out the maximum amount of auxiliary wind propulsion for the specific ship to be designed and apply electric propulsion. Fourth step is if there's no wind, what else? Fourth step is what we're working on, not necessarily the fourth step, but LNG, which is applicable nowadays quite well. And in future, consider CO2 capturing on board of the design that's applying LNG nowadays. And fifth step is R&D towards zero emission. The adaptive engine room design, as we see it, is a little more complex as presented before, but we developed quite a nice method considering different future fuel scenarios, like shown before. Next step, please. Some examples of cargo vessels we designed, extreme fuel efficient vessels. It's just to show you what kind of vessels are in our portfolio for Hartmann, Wagenborg, Bijna Barents. As you can see, next one, please. This is the Oceanic we designed for Hartmann some years ago. You might recognize the right-hand picture. This is a photograph made by Flying Focus of the design that we made, including all hull lines and the very efficient vessel. And this is the predecessor of that for Hartmann, the Deo Volente. Heavy cargo, very compact heavy cargo vessel, lower than 3000 GT, less than 3000 kilowatts, still sailing 18 knots, and she does, as most of you may know. Hull design optimization, just this picture, where we see this CFD as a very nice tool, but important is to realize that speed reduction is the way to go for an eco speed. So in our optimizations, there are projects in which we consider a top speed, say a 13 knot top speed, and the slenderness for that hull, but we optimize the lines for an eco speed on 11 knots because you will be sailing far more 11 knots. Next, please. Large diameter propeller optimization, we did a lot of investigations for the Lady Anna series. Integrated optimization of hull lines, propeller design, nozzle design, and rudder design. And the effect is quite astonishing. Next, please. This vessel, the Lady Anna series, 20 vessels of this series have been built. She has a surface speed of about 10 knots, transporting 3,000 to 3,500 tons of cargo at an average power below 700 kilowatt. Fuel consumption less than 3 tons per day. And that's in some situations more than 30-40% less than competitors. And she's keeping thrust in heavy seaways. Now do the next one, please. This is the new normal in short sea shipping. The additional thing we developed later on was the possibility for an open top hatchless notation for the same vessels already existing. So it's a retrofit hatchless vessel. The hatches are used as a breakwater with a draft limitation, extra bilge pumps. It's a very efficient project cargo shipping at the lowest CO2 emissions in a diesel version, in a simply diesel version. Third step was auxiliary wind propulsion. And here you see the picture from Flying Focus of the motor vessel Anki of Jan van Dam Shipping from Spijk. We think use this free available wind as it is on the oceans. Apply the largest auxiliary wind propulsors that do not impede operations of the vessel. Some vessels are frustrated by this kind of wind things, most not. We were looking for a very compact wind propulsor that can be retrofitted and integrated in new designs. And future will be a combination of wind energy and an electric propulsion system, as we see it. We developed the Econo wind unit based on the turboval principle of Jacques Cousteau. It took some time from 2009 to 2018. On the left, you see the CFD calculations we did together with Delft University. In the middle, you see the principle. I won't go into that, but it's a very compact wing-like device with boundary layer suction as the big trick that increases the thrust, the delivered thrust, with a factor of 4 to 5 compared to if there was no boundary layer suction. The nice thing of this compact thing is that you can put it in a container, as you can see on the next slide, and just have them fit in a 40 feet container. On the left side, you see the situation as it could be with 2 Econor wind units on a short sea vessel, transforming wind directly to thrust. And to get an idea how much thrust this can be realized with those 4 ventifoils, on the right side I projected the equivalent 165 square meter per unit that would regular sails that would deliver the same kind of thrust. Next, please. This is to show you get the container as a container on board, push a button, the ventifoils unfold themselves automatically, adjust them in the correct angle to the wind, and start delivering thrust. Next one, please. 2018, the first maiden voyage was made, and the first fuel savings already reported in the first maiden voyage, up to 8% with only 1 unit in this vessel, resulting in fuel cost estimates on the level of 2018 of 40 to 60,000 euros per year. Next one, please. This year, the Anki started sailing. Pictures with the 10-meter ventifoils. They will be extended with another 6 meter in the second half of this year, resulting in CO2 reduction and fuel savings up to 20% in both 4-5 and annual averages up to 8%, sailing Baltic and North Sea. LNG, this is the new design we made for Wayne Barents. LNG integrated in the vessel. It's quite a trick to get this big tank in. There were 7 years of R&D at Koningschip on LNG-fueled vessels. 2 series have been designed last year for LNG-fueled dry cargo ships for the Baltic. LNG is nice. It's okay for the SOx, the NOx, and the particulate matter or soot emissions, but there's still CO2 emission. So we started an R&D on CO2 capturing on board of LNG-driven vessels. Next one, please. On this same design, also this one can be hatchless. Wheelhouse and accommodations are on the forward side. It's favorable for loading and unloading and supporting the hatchless operation. Very interesting design. Next one, please. This is a picture of the companies or the parties that were involved in this R&D project we did together with TNO. Meyerwerft was also involved, FMA, Marico. Next one, please. And the big interesting thing of LNG-fueled vessels is that the exhaust gases are already clean. The capture of CO2 is a proven land-based technology and comparatively simple, not less complex than for coal-fired situations or diesel-fired situations. Feasibility study with it was focusing on applying this known technology in a vessel, on the size, the weight, the roll and pitch effects, etc. A very interesting thing is that to store the CO2 on board, you can cool it down with LNG, the cold in the LNG, and liquefy it. So CO2 is liquid at -20 and 20 bar, and the LNG is on board the vessel at -163. So that's quite a nice opportunity, and it's a big heat balance optimization, and that's the interesting thing. This is how a CO2 capturing installation would look like in a sea river vessel with a limited air draft. And right below you see the Sleipnir, the big crane vessel of Heerema. That's the subject for the project we're in now, together with Heerema and TNO, developing a concept for CO2 capturing on board of that vessel. The nice thing for the future is that you can create a closed carbon loop by this. LNG is consisting of methane. This methane burnt in the engine results in CO2. You capture the CO2 and sell it in the future as a feedstock for the producers of synthetic e-fuels. And the synthetic e-fuel methane can be used to fuel the vessel again. Then we have a closed carbon loop and the vessel is CO2 neutral in future. Next, please.
I think, Guus, I think because we are a bit short in time, and I do want to also cover some questions, and I think you already covered quite a good ground in line with the questions being asked from the viewers. To start with...
Can I do one sheet more?
Sure, go ahead.
Next one, skip this one. Towards zero emission, this is a future concept, just a concept study we're working on. 33,000 deadweight vessel, length 220 meters, applying 10 very large ventifoils. At the ship speed of 11 knots, wind can take care of 40% of the average, an average of 40% of the energy required to sail this vessel. So you can save 40% on fuel and CO2 reduction and on your installation. Next one, please. This is how it goes down. Next one, please. So this concept has 10 ventifoils, a fuel cell of 2,500 kilowatt only. That's enough to propel this vessel 11 knots, and liquid hydrogen tanks that are available on the market yet. And it's a very interesting concept on which I could talk for hours more, but that will do another time. Thank you.
I'm actually happy you showed those slides because that is a very interesting concept. There's also quite a bit of interest in these wind-based solutions in the chat function. Before we go to that, I would like to touch back on the poll. Before we started with the program today, we asked the viewers what they think is the way forward. Will it be hydrogen? Will it be a mix of renewable solutions? And if I look at your presentations, I clearly see a mix of renewable solutions.
For sure.
That is also in line with what most of the viewers thought. 56% said, hey, this will be the way forward. There's also 22% of the viewers that says, no, it will be hydrogen. So there's still a little bit of a debate going on there. But one thing I thought was most interesting is that both of you showed the Hartmann square meter runner vessels. And I think from a ship owner viewpoint, if I want to be green, that's great. But if I can be green by carrying more cargo and burn less fuel, that will be optimal. So is that where an important focus point to move more cargo with a fewer ship?
Is also one of the, but let's say that's what we did always. As a good ship designer, you always focus on don't make your ship too large. So find concepts that carry more cargo than the others, than the existing vessels. And also always focusing on using the smallest amount of power to get your speed. That was always in our DNA. That's deep in our DNA. The new thing is finding out sources that emit no CO2 to create that.
But then if you place 10 ventifoils on your vessel, won't you lose cargo capacity?
No, you don't lose. As we that was very quick. They can be folded down. They can be upwards. They're very compact. They need to be integrated in the design of the vessel. This is how you fold them down in headwinds. You don't have any extra resistance. And if you're maneuvering, you also don't have any strange effects. It's just fold them down, fold them upwards if you want to sail. They're not there yet. They're in a development. And this is a concept study which to find out what can we gain if we would develop these kind of ventifoils. And this is the direction in which we can develop the results. To integrate them in the design of the vessel is a very interesting challenge, but it's doable. We know how to integrate them.
Yeah, and
they should never frustrate the cargo operations. That's the first thing we hear all over the place. But that's possible with this compact thing. That's a nice the advantage why we choose this ventifoil as a wind propulsor. There are flattener rotors. Yeah. The flattener rotors are very hard foldable. It's almost impossible to make them foldable. And there are more things, but we think this is the most compact, delivering the most thrust in the smallest compact thing.
Okay, there's a question from Albert Jan Aars, and he was wondering about the return of investment on these ventifoils.
That's depending strongly on the area where you sail, if there's wind enough, on the number of days. In the picture for the Lady Christina sailing on the Baltic in quite regular trade, I think. At that moment in time, it was between 5 and 7 years. That's okay, but it still is for a number of ship owners. It's not automatically that you save enough diesel to use it, and that's one of the. It's doable and it's very okay to do it, but there will be in future there will be more reasons for using the sail. In our vision, it's the first step you should always take to limit the CO2 output.
Okay, thank you. Harry, also a question for you, because I asked you the poll before we went live, and on the contrary to most of the viewers, your question was, I think the way forward is hydrogen.
Yes.
Why do you think that?
I mean, I'm a little bit prejudiced by my background in aerospace, where it's the ultimate fuel. It is the ultimate fuel in terms of energy, in terms of, what energy you can get out of a kilogram of hydrogen. Volume is a problem, storage is a problem, so it has its challenges. But it's also, it's just a source of fuel that I feel would be most easy to integrate in our current infrastructure, although you do have ammonia, which also has its proponents, which is essentially hydrogen bound to another molecule.
Okay. There was during your presentation, you mentioned a lot of methods to improve hull design.
Yep.
There was a question from a viewer who said, to which extent do you verify the CFD relate to actual vessels? Because you are still only building a single design and not multiple designs.
Well, we have multiple designs in our portfolio that we have either have the sea trials information for, or that we have the towing tank tests from that were performed at an institute like Marin. And what we do for everything that we have information on is we do the validation. We check our CFD computations in different settings with different densities, different fineness of the calculation to the actual measured results that we have, and both in model scale, so in comparing to towing tank, and also in comparing them to full scale. Actually, the Hartmann M2 runner was a good example of that. The results are spot on.
Yeah. Okay, thank you. Guus, I just also wanted to touch on LNG for a bit. LNG was, about 10 years ago, LNG was really praised as the holy grail. At the moment, people seem to be sort of falling out of love with LNG. What is your view on that?
Well, that's exactly what we see happening because of the CO2 emitting of LNG. And that's why we started to do this research project already 5 years ago, starting a project on capturing the CO2 from an LNG-driven vessel, because that's a very nice combination. This LNG has nice, clean exhaust gases. You can capture the CO2 with existing technology, but you have to integrate it into your ship design, and that's quite an interesting challenge and trick for us. And if you capture it, it's gaseous, but because you have this liquefied natural gas at minus 163 degrees Celsius, it's really cold. You have enough cold available to cool down your gaseous CO2 and make it liquid. And the liquid storage of CO2 takes about the same space as the LNG, as liquid gas. So the space requirement is about the same. And there are very interesting concepts we are developing to carry this CO2 on board the vessel. And while you are bunkering LNG in future, you will be debunkering or unloading your CO2, your liquefied CO2. And for the real future, this CO2 will not be put underground in some offshore well, but it will be used as feedstock for synthetic fuels. Everybody in synthetic fuels thinks we need hydrogen, and if we have hydrogen, H2, we make all kind of synthetic fuels. But these synthetic fuels are combinations of carbon and hydrogen. And to get the carbon, you have CO2. That's the source of carbon for synthetic fuels. But to get CO2 from the air is quite a big trick, because the amount of CO2 in the air is 0.4 or 0.3% or something. It's really limited. If we provide a container with liquefied CO2 to an electric fuel supplier, he should be quite happy. So in future, you buy your synthetic fuel and you sell your liquefied CO2 back to this supplier. But this is a quite far ahead future. But it's the interesting process in which you sail with your existing LNG vessel, the LNG vessel from now, which sails on fossil LNG. the vessel is already ready. If it can, it has the space to apply this CO2 capturing installation to sail CO2 neutral in future on this e-fuels, on the synthetic fuels. And we try to make that clear to the big audience so that an LNG vessel of now is a good investment, because you can add later on this CO2 capturing installation, and then you also fulfill all requirements, all emission requirements.
I have a question which touches upon that. A question from Brandon Bolweg. He asks whether it's possible to cool the CO2 with LNG, as the LNG has to stay liquid.
No, it doesn't should be liquid. You have your LNG liquid in the vessel, LNG, but you have to make it natural gas or methane before it goes to your engines. Your engines burn on methane, on gas, and not on the liquid side. So you always have to heat up your LNG, and now you can do it with seawater or whatever. It minus 163 degrees is quite cold, so you can heat it up with all kind of stuff, up to a level of between 0 and 20 degrees, I think.
Okay, thank you. Just one last question for Harry. We are running a little late. I do apologize, but it is a very interesting topic, so maybe that's okay. Harry, one of the viewers asked, okay, so what can we do now? I think if we look now, we are hearing LNG, we are hearing CO2 in the future, we are hearing hydrogen, ventifoils. I think, is this where your modular engine room comes in to give an answer now?
Well, it definitely is possible to give an answer now with that, because of the fact, okay, we might run on diesel or on an LNG engine right now, but once a next is available, you can swap it out. Or for instance, if you go to a restricted emissions zone, you could, at the start of that restricted emissions zone, which is generally quite small, you could swap out your engine room for a battery pack, for instance, and then comply with requirements that way. But definitely, it's going to go in the way of also what Guus was talking about, incorporating ventifoils, wind propulsion, multiple different sources of fuel, just to get us through these next decades, because that's going to be the real challenge.
Okay, so one last question. Seeing as you're a rocket scientist, we heard Dirk talk about robotics in everywhere, but also in shipping. Mm-hmm. What is your view on that?
My view on that is that it's definitely coming. I mean, it's definitely going to be there. At DEC, we contributed to a joint industry project over the last couple of years with TNO, the TU Delft, and Marin regarding autonomous vessels and how we can make these. It offers so many advantages to the design of the vessel. It can make your vessel so much more efficient, and it can also make your operations so much more efficient. The technology is coming. It's going to be here soon.
Okay, thanks very much, Harry, and Guus as well. It was very interesting. We will go on to the next interview, and there we will talk about another solution which you can already implement now. But before we do, we will first look at a video by the Rotterdam Port Promotion Council.
Hi, my name is Albert Straatman from the Rotterdam Port Promotion Council. Together with the Port of Rotterdam Authority, we've created a project, cargo and break bulk community. These are the companies of the Port of Rotterdam, Schiedam, Moerdijk and other parts. And together we join forces to position Rotterdam as the break bulk and project cargo port of Europe. As a community, we participate in trade shows, we organize network events, national and international, and we connect all the companies together to position the Port of Rotterdam as the break bulk port of Europe. So, if you are interested in this community, please join us, help us, come with us and join forces to create a very competitive port in terms of project cargo and break bulk.
You do not necessarily have to invest in new ships right away if you want to make a difference. There are other possibilities to be sustainable and to be green and to even save a little bit of money. With me is Edwin Bell from ACT, and he will tell you a little bit about a software platform that can help you reduce fuel. Edwin, the floor is yours.
Thank you. Yeah, thanks for being here. Good morning to everyone. Yeah, just wanted to mention where I'm coming from, so everyone understands, what my the vision is and the vision of ACT. I think that's quite good. Starting from up north in Holland, in Groningen, gained my entire career towards the ICT and IT development. Starting also in the machine-to-machine business, and gain more into the Internet of Things to see from, how can it help society, how can it help citizens, to make their life more comfortable. And during that period of time, I think that was around 3-4 years ago, I came across to the Secretary General working in the United Nations and started there, let's say, working towards the Sustainable Development Goals, especially in cities and in municipalities. And during that period of time in my Quartermaker area, I gained a lot of information from mayors, from aldermen, from councils. From we are there, but what do we need to do? Yeah? And that triggered me from everyone has their own agenda, and it's frustrating quite a lot. Frustrating in the sense from we know that we need to do something, but no one knows how, and no one is very tangible from what do we need to do. I have a fantastic hobby, which is walking with my dog, and I came across with Han van Blanke, who has the same hobby, and Dutch people know that you talk about GBA Hilterman, talk about the development in the world, yeah. And Han was stating from we are in the maritime industry, and the maritime industry is very conservative. You are working already in the smart city, and how can technology help make more on the sustainability side? How can we combine this? Having said that, we came more or less to the idea from if we combine my knowledge and also the knowledge of the ecosystem that I'm working in, and we place that into the maritime industry, we can help deep shipping, short sea, but also the inland vessels, more to the goals and more on the sustainability side. Having said that, the technology that we have gained, let's say, towards ship owners to reduce fuel costs, because that is the most important cost side on the vessel side. But for me, it's important to reduce, let's say, NOx, the emissions from, but not only the emissions from CO2, but all emissions which are there. Yeah? Yeah. And you can do that by having, let's say, or reducing fuel. Yeah, because if you reduce fuel, you also reduce emissions. It's a correlation. Okay. So from that type of thinking, I'm also doing a lot of artificial intelligence projects, and I'm very happy that Mr. Dirk Neugebauer, who presented that, we are there already. So we don't have to look into the future. We are there. We are doing in certain verticals already projects to implement sustainability in, for example, agriculture, smart city side, everything focusing on the sustainable goals. Huh?
Yeah, but now you have created a system for maritime, for shipping.
Correct.
So how will that work?
Correct. So what we have now. So coming from the idea, the ship owners, they want to reduce cost. Yeah. We all, the society, we all want to reduce emission. We all want to go for the sustainability side. Yeah? So we have created an artificial intelligence, collecting all types of data. And that data can be either external or internal from a ship. Internal from a ship, we have then certain sensors or existing, let's say, data collectors, on a ship. Yeah. And together with reinforcement technology called ICSI, so we can, let's say, if you go for a ship and you say from, I want to reduce fuel, and the outcome of that reduction, is visible, let's say, after 2-3 days. Yeah?
Yeah.
So we want to look more into the future to say from, okay, how can we, let's say, instead of having all those options, you know, from the infinity side, how can we reduce that from a limited side?
Okay.
And those options, you know, we can integrate and state from, okay, if we now, let's say, if we are in the Carib industry, for example, or if we have a vessel in the Carib, and we state from, okay, now you can, you know, it's not needed for you anymore to heat the oil because it's already, you know, good enough.
Okay, but I think, because I think we're speaking a little bit about what we're talking about here, just so that everyone understands. You've created a software solution that will help reduce fuel consumption.
Correct.
Okay, can you explain? It uses the sensors on board, so
correct.
It will read a few parameters, things like that.
Correct.
Can you elaborate a little bit on how the system works? Or?
Yeah. So what we have is we have let's say a certain box on board. So we look at the low-hanging fruit. So how can we help the ship owners, you know, reduce fuel? So we created a few sensors onside the vessel, you know, looking for predictive, but also looking on the fuel side. That we state, for example, from, okay, you know, you have let's say a machine which is running already constantly, you know, shut it down, and that already reduces. Yeah. If we state, for example, with external data from, okay, go let's say 20-30 degrees more to the right or to the left, or the backboard, or I don't know how you call it in English. That you can already go into a flow which is also directing you to the certain destination. Yeah? Okay,
so if you where are you with the system at the moment? Do you have any concrete projects going on? Or?
Yeah, system is ready. So we have developed the entire, let's say, layer on the artificial side. Yeah? Yeah. So the integration of the data sets on the ships is ready. So we have, for example, several ship owners, and one of them is one of the leading ones, which is Vroom here in Holland. And I also saw that Holweda shipyards, you know, came into contact with one of my other partners, which is Han van Blanke. So I'm doing that together with Boy Blunk and Ruud van Rijsselvoort. Yeah. So they also said, we are very interested in to do that. So Vroom is doing the, let's say, the deep sea. So we have already some customers already also for the coast and also for the inland shipping. We have, for example, Vicom, who has also several ships. Yeah. And they are all interested from, this is what we want to do.
Okay, but ACT will supply the software solution, and Correct. It will use the existing sensors and parameters on board.
Yeah.
Or are you adding any sensors? Or?
Yeah, we are also adding sensors because, you know, ships are more or less built for 30 years. So there are a lot of existing ships already there. Yeah. They either have sensors or they need to have some. So we, with the ecosystem that we have created, let's say, sensors that we can implement into the ship. Yeah? Because for me, you know, I'm coming from the telecoms. For me, it's also crucial to have all the communication because it's the Faraday cage, you know, to be able to give that information and also present that to the cloud, for example. Yeah, and that's if you have that information from existing sensors that you're going to place inside. And what we also have is, for example, we have a cooperation with CBS, who has all kinds of data, you know, from Holland, for example, and all that existing data we include that in well. So you have external, internal reinforcement, and therefore you can let's say, looking into the future, go back and steer your vessel, reducing 30%.
30%, okay. So that is 30% is quite a lot. The project with the ship owners right now, when will those materialize, and what kind of vessels will they be?
We are starting with how do you call it? Carrier vessels. I don't know the type, because it's the 90,000 ton vessels, because that's where we can gain the momentum. Yeah. Okay. Because if you have those big vessels, they create around, which is more or less the same emission as 84,000 cars. Yeah? And if we land them into our country, and if we can reduce that by 30%, I think everyone will be happy. Everything is there, to go for the future.
Okay, I think I'm getting a cue for my time, so I have to stop the interview here, but we will definitely be looking forward to hear more about the developments. We will go for a break soon, but first we will have first we will look at the video from the Port of Rotterdam showing a practical business case right here in Rotterdam.
We zijn hier vandaag te gast bij RHB. RHB is een familiebedrijf, bestaat 90 jaar en is gespecialiseerd in het stevedoren van heavy lift en project cargo.
Goedendag, welkom bij RHB. Vandaag gaan we kijken naar de verlading van een aantal windmolenbladen in een uitgaand zeeschip. Je ziet ze hier achter me. De bladen zijn 60 meter lang en worden met 2 van onze high-speed multipurpose kranen geladen. Hier achter me zie je 2 kranen in tandem met een windmolenblad wat op dit moment geladen wordt op het zeeschip naast ons. De 2 machinisten zijn in continue verbinding met elkaar en stemmen constant met elkaar af wat voor beweging dat de kranen moeten maken. Op deze manier is het eigenlijk een soort van dans tijdens het laden van het zeeschip. In deze omgeving is het lastig te zien wat nou lang is of groot is, maar het blad wat hier tussen de 2 kranen in hangt is 60 meter lang. Vakkundigerwijze sturen de 2 machinisten met behulp van de radioman binnenboord het blad naar binnen. Ondanks dat het dagelijkse kost is voor ons, blijft het mooi om te zien hoe dit gaat.
Mike, hebben jullie ook het vervolgtransport hiervan georganiseerd?
Nee, wij zijn 100% stevedore, totaal onafhankelijk en houden ons verder niet bezig met vervolgtransporten, scheepsladingen, bevrachtingen of forwarding. We houden ons puur bezig met wat we het beste kunnen, schepen laden en lossen. Ze hebben constant communicatie met elkaar over intercom en dergelijke en hij volgt eigenlijk de ander. Dus er is de eentje die is leidend en de ander die komt daar dan achteraan. De bladen welke we net zagen zijn 60 meter. Die je hier voor je ziet zijn 75 meter en inmiddels zijn er al bladen van 110 meter in productie. We kunnen daarmee ook wel zeggen dat de windmolens een belangrijk onderdeel van onze dagelijkse werkzaamheden zijn geworden.
Hey, maar daar heb je die grote mobiele havenkraan.
Dat is de allergrootste kraan in Rotterdam.
Kan je iets meer over vertellen?
Hier achter ons zien we de LAM 600S. Dit is onze zware ladingkraan. Het is de zwaarste mobiele havenkraan in Europa. En hiermee laden we stukken tot 208 ton. Behalve dat de kraan ongelooflijk sterk is, heeft deze kraan ook een enorme precisie. Je kan hier heel secuur mee werken en je kan echt op centimeters nauwkeurig een stuk lading binnen in een schip wegzetten. Een ander voordeel van deze kraan is dat hij gewoon enorm snel is. Je kan makkelijk stukken optillen van 200 ton, net zoals dat een andere kraan een stuk van 10 ton op zou kunnen tillen. Het gaat snel, het gaat efficiënt, extreem nauwkeurig en daarmee natuurlijk hartstikke goed. Voorbeelden van zware lading zijn bijvoorbeeld transformatoren of generatoren. Vaak zijn het compacte stukken met een hoog gewicht. En verder kun je natuurlijk ook hele lange en grote stukken optillen. Inmiddels beschikken we over 3 van dit soort enorme mobiele havenkranen. Dus mocht je een heel lang stuk hebben, dan pakken we er gewoon 2. Eigenlijk behandelen we alle soorten lading. Onder andere windmolenbladen, windmolentorens, kabels van de windmolens, of, grote transformatoren, stukken fabrieken, havenkranen, mobiele kranen. Alles wat je maar kan bedenken, als het groot is en zwaar is, komt het hier langs.
Oké, Mike, dankjewel voor je tijd. Ik zie dat de kade helemaal vol ligt. Fijn dat je toch tijd hebt weten te maken om ons het een en ander te laten zien.
Graag gedaan en tot de volgende keer. We hebben hier wel een mooie ijsbalk liggen. Dat is ook wel een voordeel. We hebben al het ijsmateriaal tot 208 ton hebben we zelf.
Ja, dat is wel een aardig verhaal.
Ja. Ja.
Project Cargo Summit 2020 is made possible by Port of Rotterdam, Liebherr, Lubbers Logistics Group, Mstar and the Steinweg Group.
Ladies and gentlemen, welcome back. In this second part of the event today, we will talk about the renewables market. The wind energy market seems to be on a never-ending growth trajectory. Sorry about that. While there are also new cargo flows coming into life. We talked this morning about how hydrogen can fuel our ships of the future, but it could also prove to become a new industry, a new cargo flow. We will first have a look on what that could actually become. We will do that with Audun Martensen of Rystad Energy. He is the lead analyst for renewables. Audun, welcome.
Well, hello. Thank you for taking part of this.
Thank you for being here. So if we are looking at hydrogen, it still sounds quite far away, but we do see some concrete projects coming into life, also here in the Port of Rotterdam. Of course, it's nowhere near such a market as the offshore wind market is, but could it have could it become something like that?
Yeah, we really think that the hydrogen market will really grow going forward. It will, of course, as you say, be slower than the offshore wind market because they have basically been developing and prototyping for many years. But now with the energy transition really upon us all, we really see that governments are willing to change policies and add tax benefits so we can actually kickstart the hydrogen value chain. And we have also seen that energy companies, many actually been predominantly within oil and gas, also now embracing the hydrogen value chain. So for sure, we're going to see this to grow going forward.
So if we look at it from a sort of market perspective, from a Project Cargo viewpoint, if you compare to, let's say, the oil and gas industry, quantities of hydrogen needed for energy are smaller. Could hydrogen become something like the oil and gas industry of the future?
Yeah, it have actually the potential because hydrogen can be used in so many different ways, you know. First of all, I think it's important that we distinguish between what types of hydrogen that you have out there. You know, you have basically what we call gray hydrogen, and that is hydrogen that is made basically for the petrochemical industry and even for fertilizers. That is basically been, 96% of all the hydrogen production in Europe so far has been related to the gray hydrogen. And of course, that is quite CO2 emitting because we don't really use any carbon capture technology for that. But going forward, we see then much more use and much more investments into the blue and the green hydrogen. So blue hydrogen, that's of course, the hydrogen that is made based on fossil fuels, but then from gas. And then you can actually use the gas to convert to hydrogen. You can apply CCS to reduce the CO2 footprint. But then that hydrogen can be used for energy carrying, meaning that you can actually transport this hydrogen through distances, and that's going to be a major market for transport. Some will be by train, some will be by trucks, some will be by pipelines, but also a big deal of the hydrogen production to the end user will then be transported through vessels and ships offshore. So in that way, we really see that the blue hydrogen will really create a need here, but maybe even more going to be within green hydrogen, where we use renewable powered energy to then create hydrogen through electrolyzers and then also transport hydrogen. And I think this is where really Europe are planning now to develop. That's the green hydrogen value chain with all the different renewable energy sources that we have in Europe. So I think EU, they are actually expecting that about 500 billion euros will be invested into the green hydrogen from now to 2050. So, we will then potentially end up with a market at some point that will be a 50 billion euro market year on year and in the 2030s and 40s. And of course, that is much bigger than the oil and gas investments in Europe at the moment.
Okay, thank you. That was very interesting, actually. In terms of how fast can we expect this to grow, how quickly do you expect projects to come online or to get final investment decision?
So I think, the 2020 is going to be used to get up a lot of prototypes, and also that some technology is maturing, and also that we bring cost levels down, because at the moment we see that some of these hydrogen projects are still too expensive, doesn't really need or can't really survive without any subsidies. So I think in 2020 we really basically need to create the policies and create the investments environment for hydrogen to thrive and compete with other sources. And then we will potentially see a much bigger tick up in the bigger project in the 2030s. So I think that 2020 is more about piloting, and it's more cargo to be transported, and then 2030 is really the larger economy based on hydrogen that's going to really emerge.
At it from a macroeconomic perspective, where do you expect most of the action?
Yeah, so we know that, for example, countries like Japan is, of course, have had hydrogen in their energy plans for a long time, and they have come quite far in terms of technology. Sorry, and also using hydrogen in fuel cells, and also using that in their domestic usage. So Japan is really leading ahead here. But in Europe, we do see that there are certain nations, like we have seen Netherlands, France, and UK, where there are certain projects now being developed and projects being planned for that will help to go and create a market within those countries. But of course, I think how this will develop going forward going to be really interesting. I think going to be many countries within Europe that's going to have a play to somewhere to play in this value chain. And also going to be a very much interlinked market. We might have the energy production, power production in one country, you make the hydrogen in another, and transport that to the third, let's say over any deep sea shipping. So we really see that this hydrogen market is going to be very much interlinked, and it's very much a market where we think Europe, together with East Asia, Japan, and South Korea, will be one of the key markets in the world in the 2030s.
And will this become a offshore-driven market, or do you think it will be more like, as we see LNG, just more shore-based plants?
Yeah, it will be a mix. I think the shore-based market will be quite huge, because for example, if you look at the end users of the hydrogen as energy source, that will be the industrial sites where we would like to decarbonize their footprint, and it's going to be, for example, filling stations for trucks and even cars. And then you also have the use of power generation. So a lot of it will actually be shore-based or land-based, and we expect less so to be the deep sea shipping, but still are likely to be trade routes of energy. For example, within Europe, across the North Sea, but also down to the continent, and even maybe down to the end users consuming energy in southern and eastern hemisphere.
Okay, thank you, Audun. You will be back with us shortly to also give a macroeconomic outlook on the offshore wind market. We will first go to our next speaker, and our next speaker has concrete experience with a hydrogen project. So what does a hydrogen project mean in practical terms? With us is Randolph Weterings from Port of Rotterdam, who is involved in the Shell's project right here in the port. Randolph, welcome. Could you share your experience and tell us more about this project?
Yes, thank you very much. Slide, yes, thank you very much. So yeah, my name is Randolph Weterings. I'm program manager for the Port of Rotterdam. And what I would like to do today with you is going through basically all the projects that we have, the hydrogen plants that we have in the Port of Rotterdam, and then I will focus especially on the production side, like the Shell project that was mentioned. But before I start with explaining this picture, which basically shows all the different developments that we have in the port, I think it's good to know that the Port of Rotterdam itself, already in the Port of Rotterdam itself, already a large-scale hydrogen market exists. So each year we have around 450,000 tons of hydrogen production each year that is produced in the port and that is used in the port. So there are several companies in the Port of Rotterdam that produce hydrogen and several consumers that also use this hydrogen. This is mainly, well, it's mainly used in the refinery and the chemical industry today, but we see, of course, that it will change over time. We also have 2 pipelines currently in the Port of Rotterdam that's covering the port area, and even one is even connected with Antwerp and north part of France. So it's not really new for us. Hydrogen is there already for decades, but we see different developments in the use of hydrogen, so new sectors and increasing demand in the industry, and also, of course, different production facilities. If you can go back to the previous slide. Yes, thank you. So what we have here in this picture is basically all the different facilities today that are producing hydrogen. This is also what we see as the first step in decarbonizing, but also in the hydrogen economy, because what the previous speaker already explained is that the current facilities are based on steam reformers, so on natural gas. So this splits natural gas into hydrogen and CO2. The CO2 is going up in the air and the hydrogen is used. But we see that we can decarbonize that very fast by capturing that CO2 and store that under the ground. So that's the Porthos project, which you see on the left side of this picture. And this is the first step towards a clean hydrogen economy. We also believe that in order to scale up this hydrogen economy, we need even more blue hydrogen. So we work also on a project called H-Vision, which is somewhere in the middle of this picture, the light blue factory that you see, which is connecting the backbone together with the CO2 pipeline. And what we do over there is the plan is to use the waste gases, so the refinery gases, to decarbonize that part as well. So basically, you can see it as natural gas, but it's a stream that comes out of the processes, and we make that blue also blue. In the end, of course, we expect that it will develop towards green hydrogen, but for a lot of green hydrogen, you also need a lot of renewable power, and I think that's the issue that we have today. There's not enough renewable power yet to directly go in fully green hydrogen. So this is what we work on as well, because we believe that it will change and it will go in that direction. So in 2023, we will have the first offshore wind farm that will be connected to the Port of Rotterdam. It's a 1.4 gigawatt offshore wind farm. And then you see that the renewable power will start to kick in this system. Before 2030, we also see another wind park that will be connected to the port, which is 2 gigawatt, IJmuiden. And also in the climate accord, we have said we can adopt another 2 gigawatt before 2030. This is not secured yet, but we can handle it in the port. So with enough renewable power, this gives us the opportunity also to start with large-scale electrolyzers. And what we see is that, well, the current scale of technology is around 10 megawatt. This is really small, and we need to increase that technology. And this technology, of course, if you want to scale up, it needs a market, it needs all the required infrastructure, and that's especially what we do. So what you see in the left bottom of this picture, it's called the conversion park. This is where we work on a place where we connect large-scale offshore wind with the hydrogen backbone that will come on later. And this is an area where companies with large-scale electrolyzer plants, like the Shell 200 megawatt, like the BP Nourion with H250 250 megawatt project, can land and can place their electrolyzers. So that means a scale up from 10 megawatt all the way up to 200 to 250 megawatt. And in the next slide, I will show you the timeline, but If you can go back to the previous slide. Yes, thank you. So that means already 500 megawatt that will come to the Port of Rotterdam, and we have a couple of more projects in there as well. Because those companies said we need a place where we can start with large-scale electrolyzers, where we can have the connection and the access to renewable power, and where we can have a facility or a pipeline that connects us with the consumer. So on that place, we give the companies the opportunity to put their electrolyzer in and to scale up even further than the current projects are. And in order to connect those with the users, we work also on a hydrogen backbone, the white pipeline that you see over there. So that means that there will come a third pipeline in this area. But the difference is that it will be an open access backbone, where different consumers like industry, but also heavy mobility in roads and in inland navigation can be connected with. So we have a couple of projects like Hytrucks for heavy mobility on roads. And we have the Rhine project that we developed with several partners for the inland navigation. But if you look to the North Sea, and if you look to the energy demand that we expect, we believe that the North Sea is basically too small to produce all the renewable power that we need. So we also believe in that large amount of hydrogen will come overseas. So we work on an import strategy. So we're already discussing with several countries and companies to how can that look like, and what do you need in the port area? Because if you look to our vision that we published a couple of months ago, we believe that all the way towards 2050, the market in Rotterdam for hydrogen will be around 20 megatons of hydrogen each year, which is a significant growth, I would say. If you can go to the next slide. Thank you. So this slide gives you an overview about when we believe that these projects will be available, and then we focus on the area towards 2030. Saying in 2023, we need to be operational with the backbone, so that the open market can start, and also with the conversion park in order to serve the first electrolyzer, that large-scale electrolyzer that wants to be operational in the Port of Rotterdam. So this is the 200 megawatt electrolyzer of Shell. Both needs to have an investment decision then in 2021, so next year. That will be followed by H250, which is the other large-scale electrolyzer project in the port, 2025. It means that before 2025, we already have 500 megawatts, around 500 megawatts of electrolyzers capacity available in the port. And then in 2025, also the Hytrucks project wants to be operational with 500 hydrogen-powered trucks. In 2026, we have planned the H-Vision project, which is the large-scale blue hydrogen project. And then in 2030, this means that we move more to the import terminal. So the pilots will transfer into more larger bulk of hydrogen. And we see the next phase of our backbone project, which connecting Germany via a pipeline and also Gemmelot. I think this is in a nutshell the hydrogen strategy that we have in the port. So hydrogen will become available not only for industry, we also see it for different other industries. And we hope that we can that this plan can be operational in this timeline.
Thank you, Randolph. From a port perspective, I'm sure you do some research into what other ports are doing. Do you see similar projects taking off worldwide, or what is Port of Rotterdam's view on the global hydrogen market? Yeah, well, I think we see definitely different ports also doing this. So, for example, Japan, I think we heard it also from the previous speaker. Japan and Australia, they are, I think, the first one that will be piloting hydrogen supply from Australia towards Japan. So these locations are already working on it. And I think also for us,
it's very important that other ports also develop this, because we cannot do it alone. And also because we think that the hydrogen needs to come from other places as well, where, for example, a lot of solar power is available. In that area, also the ports need to develop the terminals in order to, well, for them exporting, for us importing the hydrogen. So yeah, we see many countries actually and many ports focusing on hydrogen today.
Okay, thank you, Randolph. We will continue with our next speaker, which will be focused on the offshore wind market. The offshore wind market is growing, it's booming, and I think everybody is looking towards this market right now at the moment for cargo. However, there are some challenges. With massive growth also come new challenges. And we will hear about those challenges from Lisette Ramirez from Wind Europe. And Wind Europe is represents the wind turbine manufacturers. Lisette, welcome.
Hi, thank you very much, Robert. Thank you for the invitation. I'm glad to be here representing Wind Europe. And actually, we represent much more than turbine manufacturers. We have over 400 members representing the whole supply chain across 35 countries. And it is especially the work of our industry experts that help us in shaping all of the policy and regulation across all of the European countries. Is it, sorry, I cannot see my slides, but is it working?
Yeah, it's working now.
Yeah, now I can see it. Thank you very much then. So yeah, as I was mentioning, I'm offshore analyst at Wind Europe, and yeah, we'll be discussing a bit on some topics touched upon today. So wind is now the cheapest form of electricity. This is for onshore and offshore. But there is a much longer journey on how the supply chain that we have today has grown for the past decades to be where we are today. So I would like to take the chance today to highlight how the supply chain has coped to adapt to the state of play. And for this, I will need to take a bit step into the past. So some of you might recognize this image. It's actually the Vindeby wind farm. It was almost 30 years back when someone thought about sitting turbines on the water for the first time in Denmark. They were only 450 kilowatts, and it was not very deep or far from coast, so like 4 meters and 2 kilometers away. So this is how the sector started, and it wasn't built overnight. It took actually many years. So where is the industry today? Today we have 23 gigawatts of offshore wind capacity across all Europe. And on average, we should remember that it takes between 5 to 6 years to build a wind farm from the moment it is consented to actually being fully operational. So if we just look at the past 10 years, we will notice that the installations have nearly tripled over those years. But it doesn't necessarily mean that we are installing 3 times more turbines, which you see also the numbers there, but we do see a steep increase in the average size of turbines installed. I'm sorry. So the question is, how did the industry got where we are today? Next slide, please. First, turbines. So this figure, I like it a lot because it's showing the range of the turbines installed every year in the light blue bars, and also in the dark blue on the horizontal lines, you can see the average of each year. So keep in mind also that the projects after 2025 could still change because they will adapt to the latest turbines available in the market by the time they do the financial investment decision, okay? So we are looking at the same period than the previous slide, and turbines have doubled in size, making the most of the new wind farms to use the space efficiently, capture more wind, and of course, as expected, to reduce the cost of offshore wind. Today, we are installing, not yet, please. Today, we are installing turbines of roughly 8 megawatts capacity, and the trend continues to go on. So on average, we will be installing 15 megawatt turbines by the end of the decade. Turbine manufacturers might not be aware, but they actually influence the rest of the supply chain for offshore wind, because of course, as the turbines get bigger, we have new challenges for how to mobilize and lift large components, where to store these turbines at ports, to mention a few. So we just saw that we're installing on average 50% more turbines. So scaling up the capacity of the turbines is not the only factor that took us where we are today. We also became much more efficient with time. And so I want to highlight 3 actions that allow our supply chain to become much more efficient. The first one is a steep learning curve. So of course, the learning process was not easy, but it has allowed us to learn from other sectors and to experience from every project that we have. The market visibility and the government support are key. For the past 10 years, we now have recurrent auctions for at least 400 megawatts across different countries, mainly in the North Sea at the moment. And these have given the sector and the supply chain enough visibility and a steady pipeline between 10 to 15 years ahead to make the required investments. Next, please. We also have a dedicated supply chain for offshore wind. This includes different components, like, for example, the fact that the industry is now adopting the 66 kV for inter-array cables in all projects, or the balance of plant, including the substation, switch gears, and all the equipment that needs to be suitable for the offshore environment too. Slip joints and new transition, not yet, please, foundation and installation methods are other examples on how we have now a dedicated supply chain. And of course, the vessels, very important part that was discussed earlier today. They serve every step of this project. So this requires a large coordination effort. And then next, please. Optimization. It was also largely mentioned this morning, and it's the same in offshore wind. There are different activities that can benefit from a regional approach. So I really like this figure because we see how, for instance, the Port of Vlissingen and the Port of Ostende, they could react to a wind farm just because the distance from port might be closer to one than other. So to give an example, contractors are also now talking to each other on looking for ways to make better use of their current assets. So to give another example, we will see some of the future projects sharing vessels to make the most efficient use of their fleet. So this is good, and it has taken us where we are today, which is 23 gigawatts. It's very good. Europe is still leading in offshore wind worldwide. But it's not enough if we want to deliver the 2030 and 2050 targets. So I will recap a bit, and now let's look also into what is coming next. So as I was mentioning, for almost 30 years, we have learned and improved our techniques to install over 5,000 turbines, but we need to sort our maritime special plans, onshore and offshore grids, and gear up our supply chain, because there is going to be a second and much steeper learning curve. To set a perspective, next one, please. We have now a 10-year period to fivefold our efforts and deliver the national energy and climate plans. So these together are telling that the European Union will have 111 gigawatts. This is a fivefold of the current installed capacity, and this means that we need to install by almost 50% more the number of turbines, but only in 1/3 of the time. So this is, again, I mentioned 10 years, when before it took us 30 years to build the 23 gigawatts. Next one, please. From that moment, we will have another 20 years for a second fivefold in the total installed capacity. So basically, there is no chance to stop for the industry. It looks like a big challenge ahead, but as every learning process, it also comes with new opportunities to our supply chain. So let's take a look into some opportunities. Next one, please. Vessels are commonly designed to be used between 15 to 20 years. However, the rapid size increase in turbines is shrinking this and making vessels to reach their useful lifetime previously than expected. Each vessel has a different function. So this is just an illustrative example and is not a fair comparison. So the figure on the right shows how 50 years of container ship growth look like. In these 50 years, the cargo ships carry over 10 times more. On the left, we also see some examples of the lifting capacity for vessels in the market. This is for installation of turbines. There is already a fivefold in this capacity in only 10 years. And this is, of course, not the only relevant factor. We also need deck space and height above the sea as one of the factors that might limit the current use of our fleets. So as vessel gets also bigger, we should ask ourselves, how any ports, will they have enough space for these large vessels? The quay length and depth will also be limiting factors. So how many ports will be able to host this? Next one, please. Ports are needed for all of the activities between the sea and land. So this is the manufacturing, assembly, and installation and operation of the wind farms. So sometimes the amount of time and money that ports need to have the right infrastructure is overlooked by the industry. Just like any wind farm, the ports also need to obtain all of the permits and have a strong business case to do the invest. So they also need to reach a financial close. The inbound logistics can also be quite complex if there is not good coordination in the supply chain, because they are delivering components from different places into the port. And even if the ports offer flexibility today, the wind industry should learn and think of the logistics in the future more like a serial production to become even more efficient. So let's give an example. It could be good to think of not yet, please. It would be good to think of dedicating the largest vessels, as I was mentioning, that will be also the most expensive, only to do some critical lifts, and the smaller ones to do other activities to not saturate also the port, which is going to be also handling multiple projects in parallel. Next one. Next slide, please. If this was perhaps not enough challenges already, there will be floating at a commercial scale too. In the next decade, we will have the first floating wind farms, mainly in France, the UK, and Norway. And by 2050, from the 450 gigawatts I mentioned before that is needed to reach decarbonization, nearly a third of it will be floating. Floating wind, as opposed to bottom fixed, carries most of the assembly onshore, so space will surely be a bigger constraint. It will be important to transfer and adapt the know-how from the bottom fixed, but also to find innovative ways to manage the logistics, which maybe other countries are already looking at. Next one, please. By 2040, around 10 gigawatts of capacity could have reached the end of the lifetime, and it will be to need repower or decommissioned. And this just takes me back to the beginning of the story. So the Vindeby wind farm that is already decommissioned 3 years ago, and it also represents how our experience today as a sector is limited, but there are a handful of projects and we will learn from them to develop new standards in the future. So the last one, just to take a recap. So to conclude, today we have a strong industry with almost 30 years of experience. We have got here thanks to the governments and developers of projects, ensuring a steady pipeline of projects. Turbines have also doubled in size, and this will continue. In the next decade, we have invested and developed a dedicated equipment and installation vessels, which also allows us to optimize the complex logistics of projects at ports. Next. However, with the turbines growing, vessels growing, and the diversification of the types of foundation that we will be installing, there will be space and logistic challenges. We will need to install more turbines than we have today at sea, but in 10 years instead of 30. This requires us to look even more into a serial production kind of logistics, combining ports, contractors, and heavy lifting activities. Because one way forward is alignment of the whole sector. So the dialogue between the different stakeholders is key to reach these agreements and move forward. Thank you very much. I hope you enjoyed and waiting for the questions.
Thank you, Lisette. That was very interesting. We will first go to the presentation of Auden, but before we go to the joint Q&A, I just wanted to ask you one question. Currently, we see companies like Offshore Heavy Transport and Scorpio Bulkers and companies like that step into the offshore wind installation market as a kind of a pure play company. So combining a lot of the different steps of the supply chain. From a manufacturer side, is that ideal? And also, do you expect a shortage there of vessels?
Well, I see there is a bit of conflicting views because there is a lot of announcement in vessels coming in the next years. We have seen large players are ordering new vessels because they are aware of the limitations of the current fleet. But at the same time, everyone is aware of the growth of the offshore market. So there are newcomers in the business, right? So there will be opportunities. We might face a few years of scarcity, let's say, I would say, but then because there are also so many new players, I don't think this will be an issue and the market will sort it out. And also related to, because you said someone with a bigger scope, and this is also something very important, that when a company or a contractor is given the full balance of plant or approach for a project, then this also gives them much more freedom on how to handle or optimize the whole process as compared to when you are handling multiple contractors and surfaces.
Okay, thank you. So we will first go to a presentation of Auden. Please stay on the line, and then we will have a joint Q&A after. Auden Martensen will come back, not to talk about hydrogen now, but to talk about offshore wind. And he will give a macroeconomic outlook on where the action will take place in the next few years. Auden, welcome back.
Hello, my name is Auden Martensen. I'm head of energy service research here at Rise Energy. Today, I'm going to talk about the offshore wind market and what we see to be in the upcoming years and what you can expect. First, let's start to look at the history when it comes to offshore wind in terms of installed capacity. So what we have seen since 2010 towards 2019 has been a major growth within the installed capacity within offshore wind. In 2010, we had only 3.1 gigawatts installed of offshore wind worldwide. And now in 2019, last year, that number grew to 27.5 gigawatts, an annual growth of about 27%. We have seen that most of that growth have happened within the European markets, such as UK, Germany, and Belgium and Denmark. But we have seen also that China has become more and more of an interesting market for offshore wind space, where they have initiated many developments on shallow water within China. And in fact, in 2019, China made up about 20% of the total installed capacity. And going forward, we do expect that offshore wind will continue to grow in popularity with falling cost, with increased focus and digitization post-COVID-19, meaning that in terms of forecast, we're expecting these 27.5 gigawatt to grow to 108 gigawatt towards 2025. And to achieve this quadrupling in installed capacity, we are going to see that the annual additions of new power production going to grow in the order of 10 to 15, even up to 20 gigawatt every year. Europe going to make up a large portion of this growth, but with China and investments and the policies they're provided by the government, we're going to see a major step up in installed capacity over the next years. And that's going to really drive most of this growth towards 108 gigawatts in 2025. If we would exclude the Chinese market and Americas and really zoom into Europe and have that broken down by countries, you will see that the main countries to drive the European market going to be UK, as well as Germany and Netherlands. And in Europe alone, we're talking about an installed capacity that will more than double from 2019 to 2025, reaching 52.3 gigawatts. We also see that there are new countries being involved in this space, more and more of the developments happening within France and also in Norway. And what is really interesting is that many spectators of the offshore wind market expected that the market to slow down in the second quarter of 2020 due to COVID-19 and due to the lack and the risk of investments. But what we saw was actually the contrary, that energy companies continued to invest more into offshore wind. So COVID-19 did not really stop any sanctioning activity. The operators and the owners really went ahead to really sanction projects in France, such as Fécamp and Saint-Brieuc, and we also saw the same projects within Germany and within Netherlands with Hollandse Kust Zuid and also Seagreen Phase 1. So in terms of the second quarter alone in 2020, we basically achieved 4 gigawatt of installed capacity in terms of financial close, and the 2019 similar number was only 1.4 gigawatt. So we saw almost a tripling in a capacity in a year when you would expect that COVID-19 would really leave investments out when it comes to offshore wind. But the reason why we're achieving this is because we have oil and gas and energy companies focusing a lot on the offshore wind side, and also because governments around the world are supporting initiatives. This is especially true for countries such as France and Germany and Ireland, Denmark and Norway that are now coming up and really open up new offshore wind areas, and also working on tendering and also roadmap to achieve more and more of offshore wind capacity over the next decade. And this is going to really help, the companies involved to really understand where are the good investments to be taken and where are the most capacity for them to add to their portfolio. And not only that, we also see that energy islands are becoming more and more of a preferred development choice, where, for example, Denmark are approving islands of up to 5 gigawatt to be built by 2030, going to increase their total capacity and really remain them to be the 4th biggest offshore wind energy producers in Europe by 2030. France also, with their 2028 target of about 5.2 to 6.2, we expect by end of 2020s, they could achieve 7.4, and then on the 6th place, we have Poland, followed then by Belgium and Ireland. And in total, the European Union will then make up potentially up to 85 gigawatts in installed capacity by 2030, still shadowing the developments in Asia, outside China, and also US. And also investments will follow from all of these ambitions. We will see that the companies involved would like to deploy a capital reaching about $76 billion in 2025. In 2019, that number stood about $37 billion. So we're going to be talking about a doubling in investments, and due to economy of scale, it's not going to resemble that quadrupling of capacity. But still, this number is quite immense, and it's something that will really benefit the suppliers within this supply chain, which can then really reap the benefits of turbine manufacturing investments, foundation manufacturing, and also installation of cables and substations of the turbines themselves. So that is really an interesting market for many of the suppliers involved within the traditional energy service space. And these investments are continuing to grow at a time when the overall oil market are quite bad and challenged. Because of COVID-19, we have seen that oil demand have been destroyed, and with that, oil prices have fallen, and investments within traditional oil and gas has fallen dramatically. And with an offshore wind investments to continue to grow, especially here in Europe, you will see that offshore wind investments in Europe will be bigger than within upstream oil and gas in 2022. And that's going to also be the case even if oil prices will recover toward 2025. Offshore wind going to still be the energy space offshore that's going to have most dollars deployed. And that is why we see now many of the traditional suppliers within offshore oil and gas will now move into the wind space. And this is also happening because offshore wind become more and more competitive. More and more projects can run without any subsidies. And if you look at the average installed turbine size from 2019 to 2027, that have grown from 7.3 megawatt, and it will reach up to 10 megawatt by 2025, and can grow even higher now. And we have now seen new technology being revealed by the turbine manufacturers, turbine size that can easily go to 14 megawatt and maybe up to 16 and potentially up to 20 over the next 10 to 15 years. With that, cost per megawatt installed will drop, and the project can become even more competitive, and yet again investments will be flowing into those markets. So this is going to be built upon, the competence within the oil and gas companies like Shell, Equinor, Total, BP are companies that have a large potential and high ambitions to grow their renewable portfolio, to continue to develop their concepts, continue to get projects in application and prove and financially close, and yet then develop these projects. So we're going to see many more of the likes of Total, Shell, and Equinor to move into offshore wind and continue to develop projects. And we really saw that now lately, where BP went together with Equinor and bought part of their portfolio in the US, and would like to team up because of these projects are so mature and so interesting for these mega energy companies to take part in. And the same happened on the supplier side, that traditional suppliers within offshore oil and gas are now also looking at offshore wind to grow their revenues. They are acquiring, they are spinning off and improving their product portfolio to really be ready to set these growth targets going forward and take part in that major trend. And we should also touch a bit on the floating offshore wind market, because the offshore floating wind market will also continue to grow going forward, but it will take some time, because still is the case that for the recently sanctioned projects, that the levelized cost of electricity is still almost twice as high for offshore wind than it is for grounded offshore wind, meaning that we have to see cost to further come down on the floating units. With bigger turbine sizes, that will happen, and learning, we will get to see improved cost. And we think that by end of 2030, we might have cost parity, where the levelized cost of electricity for grounded offshore wind and floating offshore wind will be very similar. So in that, we will expect to see more investments to be taken within floating offshore wind, but still investments will also be taken within grounded. So it's going to be hard for floating wind to increase market share significantly versus grounded wind, but it will happen. And by 2030, we expect maybe that offshore floating wind will make up about 5% of the overall capacity installed every year. And in terms of total size, cumulative installed capacity, we will then see that we might reach about 5 megawatts, sometimes end of 2020s, which yet again can then triple to about 15 gigawatt by sometimes in the 2030s. So to summarize, I will say that we expect then the offshore wind market to continue to thrive. We expect a quadrupling in terms of installed capacity. We expect a doubling in investments, where Europe will continue to double its installed capacity, and investments will actually be bigger than oil and gas. This will attract companies that predominantly been within oil and gas to take part in offshore wind, and we will see a faster development of those projects and also improved economics. Thank you so much. My name was Audun Martinsen, representing Rystad Energy.
Okay, thank you. Welcome back. I just heard that Audun had to leave the chat because we are running a little late and he had the next appointment. But we do have some questions, and we will talk further about it with Lisette. Lisette, just a quick question to start with from Yannis Xidias. I hope I pronounced it correctly. He would like to know, let me get the question quickly. What part of the market is believed to be the share of the new players? So where would they come in best?
Well, I would say that the challenges will be across different parts of the supply chain. For sure, the vessels, it's a part where we see more players getting into the field. But I would say also we are forgetting the part of the system integration, which requires basically the deployment of more interconnection between countries, because otherwise we are going to have a lot of excess of electricity in some parts. And I would say the last one will be the technology that is providing all of this connection. So for instance, TenneT is being a very leading the way already on standardizing some of these, but it has to be more competition as well. So then you can also keep reducing cost, I would say.
So if you look at it from a regional perspective, of course, Europe is still leading in turbine installations, but we do see new areas developing. Vietnam, Japan looks quite promising. But with those new areas also come new sort of seabeds, a new terrain, sort of requiring new knowledge. With these new players coming into the market, how, from a manufacturer's point of view, how can you build the confidence that these companies will have the expertise?
Well, I would say basically we already see there are markets globally that are very open to the experience of Europe, especially because we have the know-how in offshore wind with over the 30 years of experience I was mentioning. An example is Taiwan, that has been very welcoming other companies. And I think this will basically depend on the policies that are set in place in the foreign markets, but it won't jeopardize the ability of our supply chain to also be competitive elsewhere.
Okay, thank you. And if you're looking at from a regional perspective to the growth side of things, will supply chains become more regional based? So will you have local supply chains from Chinese ports, for example, for that region, Europe for that region, or will it stay quite international?
I will say we are staying quite international because we are the ones with most experience at the moment. So even if we want to develop regional hubs in the future, which is a good perspective, we also need then to ensure that everyone is trained. So you do need the expertise and the track record that we already have. But it makes a lot of sense, and we should look more into creating regional like hubs, what I was mentioning, even within Europe. If we think now of the Baltic Sea, because all of the experience is built in the North Sea, but the Baltic Sea by itself will need to have a regional and dedicated supply chain, and the same goes for all of the Southern Europe for the Mediterranean, for instance.
So one market that has been quite interesting to a lot of people has been the US market. But although it looks very promising, we've also seen some contracts been cancelled. It's not going smoothly. What are you expecting on that side? How fast do you expect it to grow?
Well, I would say the US is a very promising market in the sense that, of course, the coastline is quite big, and then it has also prominent sites for both bottom fixed and floating technology. Of course, the downside at the moment is that we see that the permitting processes are quite complex, especially in the US. And if we already have kind of complex permitting in Europe, and we're working towards simplifying this and might look more like a one-stop shop regulation and permitting, this is what we have to really transfer to other countries and say, okay, you have to simplify this, otherwise projects is not even 10 years, it can go up to 15 years or more.
Okay, thank you. I think with that we've also reached our time. I'll just ask one more time, are there any questions for Lisette? This is your last opportunity, otherwise we will go on to the next part of the program. Okay, so Lisette, thank you very much for your time, and thank you for your interesting presentation as well. And maybe we will have you again next time. Thank you.
Thank you. Have a nice day.
Okay, so we will first now start look at a presentation from the Port of Rotterdam. and we will get back after for a chat about the Project Cargo Journal and its future.
Dear ladies and gentlemen, yesterday I had the honor of opening the Project Cargo Summit. Today I have the honor of closing it. It took some improvisation, but I think that the organizers have put together a very interesting program. I hope you have found the inspiration to further grow your business. I would like to thank Project Cargo Journal ProMedia Group for their organization, the speakers for their presentation, and you for your participation. And let's hope that in 6 months' time we will be able to meet again real live here in Rotterdam for the next Project Cargo Summit, 10 and 11th of February. In the meantime, thank you. Good luck with your business, in further growing your business, but most importantly, stay healthy, stay safe.
Okay, ladies and gentlemen, before we close, just a few last remarks about our own platform, the Project Cargo Journal. It's still quite a young platform. We've only really launched in 2018, but there's been some very interesting growth this year. We almost reached 15,000 Project Cargo professionals worldwide per month at the moment. And it was quite encouraging to see that we have viewers from 77 countries these past 2 days. Now, of course, we also look ahead. We also have to deal with COVID-19. And as you see here, we had to move online because of COVID-19. So with us is our commercial director, Arie van Dijk, and he will share a little bit about what the future of the Project Cargo Journal looks like.
Thank you, Tobias. Thanks for having me. Well, first of all, I'm very proud of this event. I'm very happy that we succeeded in publishing it completely online. We worked a long time, of course, for the Project Cargo Summit. It was supposed to be the 3rd edition here, and as the tradition goes, we double each year. So we're very ambitious to even double this year also with the trade show. Well, of course, Corona hit us like it hit the entire industry and a lot of our viewers, I bet, also. So we had to anticipate on that, and that's why we shifted completely online, but not permanently. For sure, we'll come back physically, and that's planned now for this February. But what we saw with turning it online, like you said, you're very right. We are growing pretty hard with Project Cargo Journal, which is our news platform, which is also a counterpart for the summit. And the news platform allows us to be in constant connection. Well, you know that, you're the editor-in-chief, of course. In constant contact with our readers and the market and the people in the industry who build the industry. And that helps us to really internationalize this event. So we're very proud. I don't know if they've shown the picture already, but we had 70 different nationalities participating in this year's event. Well, look at the map. It's very clear where we have to work a little bit harder. Africa, perhaps Greenland, a little bit offshore there, I don't know. But all kidding aside, it's really impressive to see so many countries participating in this event from Rotterdam, which is, of course, Project Cargo port per se here in Europe. And we look forward to our next edition, which is already planned for February. Of course, these are uncertain times, so we really want to see how it develops this coming weeks.
On a scale from 1 to 10, how confident are we that it will continue?
Well, that's a real journalistic question. I think about an 8. We really want to put, because like we saw now these couple of days, there's a big need for people to come together and talk about the industry. Because there's, of course, a big economic crisis worldwide. But what does that mean? That means that governments and big industries are investing heavily in industries. And this means Project Cargo is going to grow in the coming time. And we want to anticipate that with our summit. We want to host it. We want to make people meet the industry. So that's our ambition, that's our goal, and I'm confident we can realize that.
And shall we, because in February it will be a physical event,
yes.
But we've reached quite a lot of people which we didn't reach previously. will there be an online sort of thing attached as well to address the whole world again?
Well, for sure, there will be also online because we've invested so much now in our digital presentation and our presence in the market. For sure, we will continue to do that. We've got also a mobile studio, so we can be everywhere where we want. And we'll take the studio, we'll take you, and we'll go to our trade show, and we'll make a great event.
Okay, thank you, Adi. Just for the viewers, I think for us as a medium, it's always interesting to hear from our readers, to hear what kind of information they are seeking. So if you have questions regarding stories, regarding markets, you can always shoot us an email at news@projectcargojournal.com. I think the shorter the lines, the better. But for now, thank you for watching, and hopefully we'll see you next time.
Project Cargo Summit 2020 is made possible by Port of Rotterdam, Liebherr, Lubbers Logistics Group, MStar and the Steinweg Group.